Hey folks, I want to do one more problem to round out the chapter. I want to look at number 45 from the back of the chapter, and it reads, Susan's 10-kilogram baby brother Paul sits on a mat. Susan pulls this mat across the floor using a rope that is angled at 30 degrees above the floor. The tension in the rope is a constant 30 newtons. The coefficient of friction is 0.2. Use work and energy to find Paul's speed after being pulled 3 meters. So already this sounds pretty familiar. I think our first problem is a really close analogous problem, even down to the numbers that were used. I'm going to draw Paul as a very angular child. It's just going to be a box. And then we're going to pull on Paul at some 30-degree angle here. 30 degrees. And we're saying that we have a tension in here, tension equal to 30 newtons. Just like that problem from before, we know that we have a 10-kilogram child rather than a 5-kilogram mass. Mu is still 0.2, and since we're moving, we're assuming that this is our kinetic coefficient of friction. And the thing is, we want to use energy here, work and energy. We don't want to use Newton's laws to really figure this out too much. Now, we're still going to need a little bit here because our friction force does require us to know something about the normal force. And our normal force, if we draw a quick free body diagram, I have mg, I have my normal force, I have this friction force, and then I have this tension, and this is where things deviate from that first problem. I have a x component of tension and a y component of tension here. And so to figure out Fn, I actually do need to do a quick sum of the forces in the y direction. Say that Fn plus Ty equals mg, but really we're going to say negative mg here, equals 0. We're not going up or down. So now I can say Fn equals mg minus tension times, I would say, sine of 30 degrees. Okay, that's all we're going to do with Newton's 3 laws for now. What we really want to do is say, what's doing work in my system? Because that's how my kinetic energy is going to change as I pull, or as Susan pulls Paul across the floor. So the things doing work, we said that gravity did no work. Gravity didn't do any work because its force is perpendicular to the motion of this box. Likewise, normal force wouldn't do any work as well, for the same reason. So I have really 2 forces doing work. I have the work done by tension and the work done by friction. So that way, when I say what is the work external, right? What's the external work done on this system of Paul on the mat? It's going to be the work of tension plus the work done by friction. We already know that friction is going to be a negative work, so we expect something smaller for our total work done, smaller than our tension work. But this should be equal to the change in kinetic energy for our system. So let's get to figuring out what these different works are. We know, just off to the side, that work can be written as F dot delta x. Another way of writing that, the magnitude of F times the magnitude, let's get rid of that, magnitude of delta x times cosine at the angle between them. So I know that I'm moving straight to the right. I have my tension force as 30 newtons times 3 meters of displacement times cosine of the angle between them. Well, the angle, right, if I'm thinking my displacement's along the floor, the angle between them is 30 degrees. And so I get, let's see, 30 times 3 times cosine of 30 degrees. I get a total of 77.9 joules of work done by tension. Now what's nice about this is I didn't need to figure out the x component, the y component, and all that jazz. It just did this amount of work. If I think about friction, I need to think about what that normal force is, right? So I have mg, I have m, which is 10 kilograms times 9.8 meters per second squared, minus my tension, 30 newtons, times sine of 30 degrees. Okay. Let's actually change this bracket style. Make it nice and easy. That's all going to be multiplied by the coefficient of friction, 0.2, times our displacement, 3 meters, times cosine of 180 degrees, which we know is going to be -1. And so when I calculate all of this out, I do 10, 9.8 minus 30 times sine of 30 multiplied by 0.2 multiplied by 3, and I get negative 49.8 joules. So when I look at the total amount of work done by the environment, 77.9 minus 49.8, I get 28.1 joules done. Now we're not done. We're not finished. We want to know what Paul's speed is. So we got to finish this relationship. We know the amount of net work done. We need to see that that's equal to the change in kinetic energy, 1/2 mv squared. Now this expression, 1/2 mv squared, is the second expression that I expect folks to just have in the pit of their stomach, right? There was 2 expressions I said a while back that I expect everyone coming out of Physics 1 to know in the pit of their stomach, at the core of their being, that I could break open to your apartment at 3 o'clock in the morning, shake you awake, and say, what did you learn in Physics 1? You would be able to say F equals ma, and kinetic energy equals 1/2 mv squared. These 2 things are just like the bedrock of everything that we kind of do further on. It's fundamental. So have those in your back pocket. Now, we're assuming that Paul starts at rest, so the initial kinetic energy is 0. Any work that we do is going to be equal to the final kinetic energy that we have, so just 1/2 mvf squared. I know m is going to be 10 kilograms, so I can now start to do all this. 28.1 joules divided by 5 kilograms. Right, 1/2 of 10 is 5. Take a square root of the whole thing. You get V final. I get V final. Right, 28.1 divided by 5. Take a square root. I get V final equal to 2.37. I think the book rounds that to 2.4 meters per second. So I would argue that this is, I kind of took my time and wrote things out a little bit more here. I would argue that this method is a little bit quicker, or at least a little bit less algebra heavy than the forces only approach. So that's number 45. Thank you for watching this. If you have any questions, please email me or see me in an office hour. Bye.